Hello and welcome to the Siemens KNX technical description of the application. For KNX commissioning with the ETS configuration software, the ETS database entry and an application program description describing the functions, the parameter settings, and the communication objects are required for the corresponding devices. At the same time, technical information is required for installation, assembly, and wiring. These documents can be found for each product in the Siemens Gamma Product Database. You can start the Gamma Product Database with the following QR code. You can select the product by clicking on the chapters. There, all products are categorized according to their application and characteristics. Or you can find the product you are looking for via the order number, MLFB, or via a short text. In this way, the modular thermal drive actuator used in the application, RL605D23, would be found. The ETS database entry is loaded here. Usually, the Siemens ETS database entries are already available for selection in the ETS online catalog and only need to be inserted into the project. The corresponding application description for ETS parameterization can be found here. The operating and installation instructions, the technical product information, can be opened here. Video commissioning with the ETS commissioning includes setting the device parameters and linking the data points between the devices via the group addresses. We used ETS 6.1.0, the current version, when the video was created. The project is already prepared. The product data of the devices required for the application have already been inserted into the project from the ETS online catalog. Alternatively, if product data cannot be found in the ETS online catalog, the product data can be imported individually. To do this, use the corresponding asterisk. NXPROD file from Siemens is loaded via the Siemens Gamma Product Database. The Siemens Touch Control TC5 Room Operating Unit, the RL605D23 thermal drive actuator, and a presence detector wide have already been created. All devices have already been assigned a suitable physical address, which has been loaded. The necessary group addresses for linking the data points have also been prepared. The Touch Control TC5 is to be parameterized first. This room control unit is a very powerful device with many functions. The focus here is exclusively on the settings that are necessary for operating a room temperature control. In the parameter card, General, and General Settings, we activate the color strip function. This was already mentioned at the beginning. It is an LED color strip in the lower area of the room control unit. This is used in the application to visualize the heating mode. It should light up red at a control value greater than 0%. The color strip parameter card appears. When parameterizing the color strip, you should take into account that if the color strip is permanently switched on, this will affect the accuracy of the indoor temperature measurement. Also, the duration of the switch on time should not be more than 8 hours per day, as this affects the LED service life. We set the parameter, color strip working mode, to always active, and the parameter, color strip working mode, when active, to permanent on. Now, 3 different communication objects are available as triggers for the LED color strip. We will later use the communication object that activates color 2, for example, red, for heating. In the Home Page parameter card, up to 5 start pages can be created, and various display elements can be selected on the home page. We remain with the standard settings for this application. I name the available home page 1, Meeting. Here you can define the layout of the icons on the home page. We leave the standard setting 4. 4 function pages are also individual symbols, and thus, individual functions of the function pages could now be assigned to these 4 navigation links on the home page. For example, page 1 lighting, page 2 shading, etc. The function pages for these links are created under the parameter card, function pages. For example, page 1 lighting or page 2 blinds, etc. For room temperature control, however, there is a special feature here in the display. The HVAC functions, such as general temperature control, floor heating, or the VRV/VRF interface, are only available from function page 6 or the subsequent pages such as 7 to 15. One could configure as many as 10 room temperature controllers. That means we activate function page 6 and then select the page function, General Room Temperature Control, for this function page. We can still name a heading for this page, for example, Heating. The setting, Operation Mode, is important. Here we select Subordinate. This means that the Touch Control 5 only supplies its room operating mode, its set point in comfort mode, and the measured actual temperature to the controller of the thermal drive actuator. The actual temperature control with the evaluation of the presence or window status is carried out in the controller of the thermal drive actuator, as already explained. We leave the temperature value from Setting at Internal Sensor by default. The weighting is then also carried out in the thermal drive actuator. For the minimal possible setpoint value and maximal possible setpoint value, it makes sense to limit this range to 16 degrees Celsius to 26 degrees Celsius. This range refers to the basic setpoint in comfort mode. In case of an operating mode changeover and the associated setpoint reduction in heating mode, a sufficient setting range is thus available. A fan function is not used here. We leave the room temperature control mode at Heating by default. This is then also displayed exclusively on the operating page on the TC5. The room operating mode is activated by default. Local operation is not blocked. If we want to optionally integrate a presence evaluation for operating mode switching, this evaluation is carried out in automatic mode, similar to time switch commands for operating mode switching. In manual mode, for example, with exclusive operation via the TC5, the presence detector is not taken into account. For this purpose, we create a function for switching to automatic mode on page 1, for example. Since this is a pure on switching function, we select Send Value with the data type 1 bit. The value content for short key press is exclusive 1. For example, via this function, we later activate the automatic mode. Switching to manual mode is done automatically when the operating mode is switched on the TC5. Via the parameter card temperature sensor, one could set an offset to the measured value in case of unfavorable detection conditions. We leave this and all other settings in this regard at the default values. After the settings has been parameterized so far in the TC5 room operating unit, the set room operating mode, the actual current temperature, the basic set point in comfort mode, and the automatic mode must now be linked to the thermal drive actuator via a group address. To do this, we switch to the view for the communication objects of the room control unit and drag the respective communication objects into the already pre-parameterized group addresses. This means that the communication object 912, the actual temperature value, is moved into the group address 002, actual temperature value, room control unit. The communication object 276, the room operating mode, is moved to the group address 001, room operating mode, and the communication object 258, the basic set point, is moved to the group address 004, temperature control basic set point. To activate the automatic mode, connect the communication object, page 1 symbol 1 send 1-bit value, to the group address 008 automatic mode. To control the color strip, we connect communication object 951 color strip 2 trigger to group address 007 status heating, and in addition to receiving the status of the active room operating mode from the thermal drive actuator, we link the communication object 275 page 6 heating, reception, operating mode, with the group address 009, status room operating mode. Now the parameters of the thermal drive actuator are set. First of all, we have to enable the temperature control. To do this, scroll down in the parameter card, Device Settings, and enable the desired controller. The new parameter card, Temperature Control 1 inch appears. We change to this one. We use the System Type 2-pipe system for our pure heating control. This is the standard setting. Of course, we only select heating for the controller mode parameter. We do not need the fan control, and we can leave the numerous status objects in the standard settings for this application. With this, we switch to the room operating mode parameter card. We can also use most of the parameter settings by default. In the pre-selection of room operating modes, we use all 4 room operating modes: comfort, pre-comfort, energy saving mode, and protected mode. In principle, we could also limit the number of room operation modes here. The communication or the switching of the room operation modes in manual mode is carried out by default via 8-bit communication objects. This setting remains. With older KNX devices or with push buttons, the room operation mode changeover is often carried out via 4 individual 1-bit communication objects. Since we receive a presence signal from the presence detector for switching to the comfort room operating mode, we must enable the presence receive object in the presence parameter. If window contacts are to be optionally evaluated via binary inputs, up to 4 communication objects for receiving the window status can be set here in the window contacts parameter. We select one contact here as an example. If several window contacts are set, they are internally connected via a logical OR operation. This means that if a window is open, the controller switches to the room operating mode, protected mode. Further parameter settings for the window contacts appear. You can set a delay time for the reaction to an open window. This is very useful so that a room operating mode changeover does not occur immediately when a window is opened briefly. The standard 30 seconds is a good value here. You can also invert the window contacts or report the status of all window contacts via a 1-bit object on the KNX bus. For our application, we can leave these parameters as they are. In the Room Operation Mode Status section, you can disable or enable the pure status of the room operation mode in manual mode. This is the status of the room operation mode, as it was only set in manual mode via a room control unit. Enabling is not necessary here. However, the status of current room operating mode, which takes into account a changeover of the room operating mode in manual and automatic mode, must be enabled. This also gives us the status change when the presence detector changes the room operating mode within automatic mode. This status is then later reported back to the room control unit and shown accordingly on the display. The calculator must be parameterized before we make parameterizations in the actual temperature value parameter card. In this application, the actual temperature value of the room control unit and the actual temperature value of the presence detector are to be weighted via the calculator, and the result is to be assigned directly internally to the actual temperature value of the controller. We open the calculator parameter card and select the temperature in degrees C in the calculator 1-inch parameter. This opens another parameter card, calculator 1, temperature. In the parameter calculation type, the weighted value is already preset. The number of inputs is also already set to 2. One for the room control unit's value and one for the presence detector's value. With the 2 input values, one could also set an offset in Kelvin here to correct unfavorable detection conditions. We leave this at 0. Via the weight parameter, each of the 2 sources can now be weighted via a weighting level from 1 to 255. We select weighting 2 for input 1, which will later be linked to the room control unit via a group address. We select weighting 1 for input 2, which will later be linked to the presence detector via a group address. For example, we take the temperature value of the room control unit into account at 66.6% and the temperature value of the presence detector at 33.3%. Of course, this is only an example. The installation locations and associated ambient conditions should be precisely evaluated during project planning. The calculated result of the calculator is later linked internally with the room temperature controller. In this respect, no further settings are necessary for this parameter card. Now we change to the parameter card, actual temperature value, and change the parameter, source of actual temperature value, to calculator evaluation. In the next parameter, selection calculator, The result of calculator 1 is already preset, as we have only parameterized one calculator. If you have parameterized several calculators, you can assign them here from the existing selection. Monitoring of the actual temperature is not provided in this application. Heat alarm and frost alarm remain in the standard setting. Now the set point setting is parameterized. This is done via the Temperature Set Points parameter card. The set point transfer from the room control unit to the room temperature controller takes place via the basic set point with a possible set point shift. This is set by default. In the other parameters, the default values for the basic set point heating, the set point shifts for pre-comfort and energy-saving modes, and the temperature value for protection mode in heating mode can be set. We leave the default values. These are sensible. The basic set point object must be enabled for linking with the room control unit. All other parameter settings on this card remain standard. Now we come to the last parameter settings regarding the control behavior. We open the parameter card, Heating. Here you can choose between a 2-point control and a pi control for the control behavior. We leave the standard pi control. In another parameter, you can select the system type for the heating. With this, the pi control is designed according to the system type. That is, according to the selection: fan coil heating, heating ceiling, underfloor heating, or radiator heating. The appropriate values for the proportional range in Kelvin and the reset time are already offered. Individual, user-defined settings are, of course, also possible. Here, we select the radiator heating setting according to our application. Sequence control is not provided in this application. The type of control value output is, by default, via a continuous signal, 8-bit, and is transferred internally to the control value output. To do this, we change to the parameter card, a thermal drive. We select the parameter card, Control Value Configuration. The type of control value is already correctly preset as continuous, 1 byte, with pulse width modulation. However, the parameter, source of control value, must be changed to the internal temperature controller, as the control value will be transferred internally between the controller and the thermal drive control. The source for the control value is selected in the next parameter. This would then be temperature control 1. All other parameters on this card can remain in the standard setting. On the parameter card, Functions, Objects, as a subcard of a thermal drive, you can select the setting of the valve operation. This parameter is very important because it takes into account whether de-energized closed or de-energized open thermal actuators are to be controlled. Valve rinsing can also be set via this parameter card. Manual valve rinsing, for example, via a push button, or automatic valve rinsing, for example, weekly or demand-oriented, is highly recommended. Other parameters on this card can remain as offered by default. This completes the parameterization of the thermal drive actuator, and we switch back to the view of the communication objects for the thermal drive actuator in order to connect the relevant communication objects with the prepared group addresses. This means that the communication object 343, the room operating mode, manual operation, is assigned to the group address 001, room operating mode. The communication object 344, the room operating mode, automatic mode, is moved to the group address 008, automatic mode. The communication object 374, the basic set point, is connected to the group address 004, temperature control basic set point. So that the calculator receives the two actual temperature values from different sources. Communication object 808, calculator 1, temperature value 1, for example, the value as sent by the room control unit, is assigned to group address 002, actual temperature value, room control unit, and communication object 809, calculator 1, temperature value 2, for example, the value as sent by the presence detector, is assigned to group address 003, actual temperature value, presence detector. For presence switching, we connect the communication object 366, presence, with the group address 005, presence. The group address 006, Windows State 1, is prepared for the evaluation of window contacts. This is connected with Communication Object 367, Window 1. Since this function is optional in the application, number 1-bit communication object of a KNX binary input was placed in this group address. As required, this can be connected to a binary value, for example, from the binary input device N262DX1 or the push-button interface up 220. The thermal drive actuator sends the status for the room operating mode back to the room control unit TC5 via the communication object 355, room operating mode status. For this purpose, the object is linked with the group address 009, status room operating mode. For the control of the color strip on the room control unit, we link the communication object 26 status control value, 1 bit, with the group address 007, status heating. Let's move on to the configuration of the last device, the presence detector wide. We select it and switch to the parameter view. For the presence detector wide, presence detection and temperature measurement are already preset by default, as you can see in the Device Settings parameter card. In the Presence Detector parameter card, we can use the parameter settings for the pure presence detection required for this application. The Temperature Sensor parameter card settings are also adopted this way. An offset should not be parameterized for the temperature value of the presence detector. Via the view of the communication objects for the presence detector, we connect the two communication objects, 22 presence detector, start, A, and 26 presence detector, end, C, with the group address 005, presence. In this way, the thermal drive actuator receives the information about the beginning and end of a presence in the room. Via the communication object 79 temperature sensor, temperature value, the presence detector supplies its actual temperature value from the ceiling to the calculator of the thermal drive actuator. The object is connected accordingly with group address 003, actual temperature value, presence detector. In the end, the device parameterizations and the links with the group addresses are loaded into the devices via a KNX interface, and the functioning of the application is checked. Finally, the group address is used and, thus, the linked data points are to be shown. Via the group address 001, the room operation mode set on the TC5 room control unit is transferred to the controller of the thermal drive actuator. The actual temperature measured at the TC5 room control unit is transferred to the calculator of the thermal drive actuator via group address 002. The set point set on the TC5 room control unit is transferred to the thermal drive actuator controller via group address 004. The automatic mode activated on the TC5 room control unit is transferred to the thermal drive actuator controller via group address 008. Via group address 007, the heating status is transferred from the control value output of the thermal drive actuator to the room control unit TC5 to activate the red color strip. Via group address 009, the current room operation mode status is transferred from the thermal drive actuator's controller to the display on the TC5 room control unit. The actual temperature measured at the presence detector wide is transferred to the calculator of the thermal drive actuator via group address 003. The presence signal detected at the presence detector wide is transferred to the controller of the thermal drive actuator via group address 005. The group address 006 is optional. The window status, which was detected via a digital input, can be transferred to the controller of the thermal drive actuator. The ETS project created for the technical application description is available as a sample template. Use the link or the QR code to download it. We have now reached the end and would like to thanks for watching, and see you soon in one of our next videos about Gamma KNX.